This is a gate problem on precision rectifiers, and precision rectifiers are circuits which comprise of operational amplifiers along with the diodes. And the question is stated as follows. So sketch the transfer characteristic curve of the circuit shown below. So transfer characteristic curve means that we have to plot for V0 versus Vi, and this is different from the normal characteristic curves which plots for maybe V0 versus time and Vi versus time. So for transfer characteristic, we are looking at a plot of y-axis being V0 and x-axis being Vi. So for solving this sort of question, you have to break the waveform into two parts. The first part will be a positive half cycle of the waveform, and then in the next part we will look at the negative half cycle, and we will see as to how the diode behaves, whether it is acting as an open circuit or whether it is acting as a short circuit. Note that the diode considered here is that of an ideal one. So an ideal diode is a short circuit when it is in conducting mode or it is in forward bias mode, and it behaves as an open circuit or open path when it is in reverse bias condition or it is in non-conducting state. And if we refer back, the diode was such that the anode was at this position and the cathode end was at the other end. So when you are going to solve this sort of question for the positive half cycle, note that if this voltage is going positive and this is an inverting connection, so the output here will go negative. And similarly, if this is going positive, again this is another inverting connection, and so we can expect that the output over here will be going towards negative voltage. And so if this is a negative voltage which is applied on the anode side of the diode, then this diode will behave as an open path. This diode will be in reverse conduction mode, basically in non-conduction state, and therefore you can replace this diode with an open path, and therefore this amplifier over here does not have any feedback and it can only behave as an open loop comparator. So if we look at the upper part of the circuit, we find that here is the input voltage Vi, which is of course taking a shape like so, and if I assume that some current is going to flow through this 10 kilo ohm resistance, the only path that it can take is either through this one or through the other one, and both of them are going to go into the input terminal of an op-amp. Now for an ideal op-amp, as mentioned in the question, the input terminals will provide infinite resistance, or they will basically prevent current flow into its input terminal, and therefore no current flows through this path, no current can also flow through this path, and definitely no current can flow through this open loop part. And therefore the current that flows through this 10 kilo ohm resistance is 0 amperes, and therefore the voltage drop across this resistance is also 0 volt. And so if this node voltage is at Vi, this is also at Vi, and because of virtual short due to presence of this negative feedback, you have Vi over here also, and therefore the current that flows through this branch is equal to 0 because both the nodes are at Vi potential, same potential, and therefore the voltage drop through this 10 kilo ohm resistance is also 0 volt, and therefore V0 is equal to Vi. So for the positive half cycle of the input voltage, the output voltage will simply track this input voltage, and therefore this is a linear relationship. If I consider the relationship to be y is equal to mx, then y is equal to V0 and x is equal to Vi, and therefore m is equal to 1. So the slope is 1, or this angle is equal to 45 degrees, and therefore if this is Vi and this is V0, then this is the characteristic of the transfer characteristic curve when the input is a positive half cycle. Now, if we proceed with the negative half cycle behavior, so this is the negative half cycle for the input voltage, and it's easy to understand that if it was open circuit in the previous case, this time it will be a short circuit, because if I apply a negative voltage here, this will turn out to be positive, and then it will force this diode to go into forward bias condition or in conducting mode, and an ideal diode will behave simply as a short circuit. So if this part behaves as a short circuit, then this configuration is that of a voltage follower, or in other words, the voltage at this node, this is 0 volt, is the same as the voltage at the other node, which is also 0 volt. And then you have this to be another resistive configuration, and there is a negative feedback here, so the voltage here is also 0 volt. And we can easily frame the nodal equation, or maybe we can look at this part of the circuit and then state that this is a inverting amplifier, and therefore V naught is equal to negative of 10 kilo ohm by 10 kilo ohm multiplied by Vi, which is equal to negative of Vi. And therefore this is an opposite relation, or in other words, the slope here is minus of 1. So this is still linear, but the slope is negative 1. So if we look at the transfer characteristic curve in the positive half cycle, we found it to be having a slope of plus 1, and in the negative half cycle we found that the slope is equal to negative 1. So basically this behaves as a full wave rectifier.